Welcome to my class Chemical Reactions and Equations, class 10 for all boards CBSE, SCRT and ICSE. This lesson is very useful for all competitive exams. In our day-to-day life, we observe so many changes like ripening of fruits, rusting of iron, burning of candle, boiling of water. If we observe these changes, not only these changes, so many changes we observe in our day-to-day life. Few changes are temporary changes and few changes are permanent changes. Few changes are temporary and few changes are permanent. In your previous classes, you studied these temporary changes are known as physical changes and the permanent changes are known as chemical changes. Physical changes and chemical changes. In the above example, see, boiling of water is a temporary change. Why? Because you can get back the initial substances. There is no change in its molecular composition or any new substance is formed. At the same time, melting of wax is a physical change because wax is in solid state. When you heat the wax, solid state turns to liquid state, and when you go on heating further, it turns to vapor state. Means there is the change in the state. If you cool it, you will get back the initial solid wax. Whereas burning of candle is a physical and chemical change. Physical change is there and chemical change is also there. See, when the wax melts, see, you will get the flame in the candle. See, on burning the candle, it gives carbon dioxide and water vapor. So, new substances are formed. At the same time, if you observe the rusting of iron, iron loses its shiny surface due to the action of atmospheric water vapor and air. So, rust is formed. A new substance is formed. At the same time, ripening of fruits, there is a change in the color after ripening. So, you can't get back the original color. So, that's why ripening of fruits, rusting of iron is a chemical change. Whereas boiling of water, melting of wax is a physical change, but burning of candle is both physical and chemical change. Let us discuss the more scientific definition for a chemical reaction. What is a chemical reaction? A chemical reaction is a process in which new substances with new properties are formed. What is a chemical reaction? A chemical reaction is a process in which new substances with new properties are formed. It is called chemical reaction or a chemical change. What is that? Chemical reaction or a chemical change. A new substances with completely different properties are formed in a chemical reaction. Example, magnesium bonds in the presence of oxygen to give magnesium oxide. Magnesium is a solid, ribbon is a solid, and oxygen is gas. Magnesium oxide, white ash, it is a new substance. In the same manner, you take the case of hydrogen and oxygen. Hydrogen is a gas and oxygen is a gas. Next, they form water. They form water. See here, the initial substances are hydrogen and oxygen, and the new substance is water. A new substance is formed. Zinc and hydrochloric acid react with each other to give zinc chloride and hydrogen. New substances are formed. So, these new substances are formed with completely different properties. Substances with new properties are formed in a chemical reaction. Now, what do we call these new substances which are formed in a chemical reaction? These new substances are called products. Next, the substances which undergo chemical change are called reactants, means the initial substances that are present in a chemical reaction are known as the reactants, and the new substances that are formed are known as products. The reactants are always written on the left hand side and the products are always written on the right hand side. Observe this one. Observe this reaction. Magnesium bonds in oxygen to give magnesium oxide. See this one. Magnesium and oxygen. These are the initial substances. So, magnesium and oxygen are known as the reactants, and magnesium oxide is a new substance, new product. So, magnesium oxide is known as the product. Here also, hydrogen and oxygen are the initial substances. So, they are known as the reactants. So, they are written always written on the left hand side. Next, water is a new compound. Water is a new compound. It is written on the right hand side. It is the product. Here also, zinc and hydrochloric acid. These are the initial substances. These are the products, zinc chloride and hydrogen. So, they are written on the right side, and zinc and hydrochloric acid, the reactants are written on the left hand side. The reactants and products are separated by directed arrow. So, the direction of the arrow always indicates the direction in which the reaction is proceeding. So, initial substances to new substances, reactants to products. Let us discuss what are the characteristics of a chemical reaction or a chemical change. Let us discuss few of the characteristics of a chemical reaction. So, the first characteristic, change in the state. What is that? Change in the state. Example, here I am giving an example, burning of candle. Burning of candle. When a chemical reaction takes place, sometimes there is a change in the state. When the candle is burning, see this one. If the candle burns, you will get the flame. Next, at the same time, carbon dioxide and water vapor, the new substances are formed. So, wax is in solid state. This candle is in solid state. When it burns, see, it converts to gaseous state. Carbon dioxide is a gas and water vapor is a gas. So, there is a change in state. Okay, this is the first characteristic of a chemical reaction. In all the chemical reactions, there is no, we should not predict change in the state takes place. In some chemical reactions, change in the state takes place. Let us discuss the second important characteristic of a chemical reaction, that is change in color. For that one, the reaction between citric acid and potassium permanganate. Actually, potassium permanganate is purple color. It is in purple color. When you add citric acid to it, few drops of citric acid to it, you will get the colorless solution. Another example for change in color is ripening of fruits. What is that? Ripening of fruits. Let us do an activity to prove change in color also takes place in a chemical reaction. For that one, take a test tube and a pinch of potassium permanganate in it. Prepare potassium permanganate solution. Add some water to the pinch of potassium permanganate already taken in the boiling tube. Observe the color. What is the color? The color is purple in color. Observe the color carefully. You can see the purple color clearly. Take a part of potassium permanganate solution in another test tube. In another test tube, add few drops of, observe this carefully, add few drops of citric acid. Observe this carefully. I am adding few drops of citric acid. Citric acid is nothing but a lemon. Few drops of lemon juice I am adding. Observe this one. See, do you find any color change in it? See this one. You can clearly observe the purple color vanished. Okay, now it became the colorless solution. There is no purple color. There is no purple color. So, with this experiment, we can say that there is the change in color in a chemical reaction. So, change in color also takes place in a chemical reaction. Let us discuss another important characteristic of a chemical reaction is evolution of gases. We will do an activity to prove gases are evolved in a chemical reaction. To prove that one, what are the materials we need? Zinc granules and dilute hydrochloric acid, or magnesium ribbon and dilute sulfuric acid. Let us do an activity to prove gases also evolve during the chemical reaction. Let us do an activity, lab activity, to prove gases are evolved in a chemical reaction. For that one, you need a test tube and few pieces of magnesium ribbon or few granules of zinc, but I have taken only magnesium ribbon because it is available with me. I don't have zinc granules. Okay, now take few pieces of magnesium ribbon, a small piece of magnesium ribbon in the test tube. Add diluted sulfuric acid. See this one. What I am doing? I am adding dilute sulfuric acid. Observe this carefully. As soon as I added dilute sulfuric acid, a gas is formed. Observe this one. Reaction is going on. Reaction is going on. A gas is formed. A gas is formed. Let us test the gas evolved in this reaction. What gas is evolved? See, bubbles are formed. So we can say that some gas is evolved. Some gas is evolved. Let us test the gas. See this? I am bringing the burning matchstick near to it. Observe this one. The flame is put off with pop sound. The flame is put off with pop sound. So, which gas put off the flame with pop sound? Hydrogen. So, in this reaction, hydrogen gas is evolved. Once again, we test the gas evolved. See this? Once again, I am testing. Okay. So, the flame is put off with pop sound. With this, we can say that in this chemical reaction, gas is evolved. So, the reaction between magnesium ribbon or magnesium metal and dilute sulfuric acid gives a hydrogen and magnesium sulfate. Magnesium sulfate. So, with this experiment, we can say that gases are evolved in this chemical reaction. Let us discuss another important characteristic property of a chemical reaction is change in temperature. Let us verify this. Heat changes takes place in a chemical reaction with an activity. What are the materials needed to prove that one? See, we need laboratory thermometer. What is that? Laboratory thermometer and another chemical quicklime, or any other chemical reaction we can take to prove this reaction. Let us observe this activity clearly. Let us prove heat changes takes place in a chemical reaction with the previous experiment. See this one, this is the clinical thermometer. Now the reading in the thermometer is 34 degrees centigrade. Observe this carefully. 34 degrees centigrade. How much? 34 degrees. Okay, 34 degrees. Is it visible? 34 degrees centigrade. You observe this one. This is 34 degrees. See this. 34 degrees centigrade. Now, see, I kept the thermometer in this test tube. Observe the reading of the thermometer. Observe this carefully. It reached 60 degrees. It reached 60 degrees. So, with this experiment, we can say that heat changes takes place. Because of the heat changes, there is the rise in the temperature. So, in this reaction, that is the reaction between magnesium and diluted sulfuric acid is an exothermic reaction. Heat is liberated in this chemical reaction. So, with the same experiment, we can prove that heat changes also takes place in the chemical reaction. Let us discuss another important characteristic property of a chemical reaction is formation of precipitate. In some chemical reactions, precipitate is also formed. It is also one of the characteristic property of a chemical reaction. For that one, what are the materials we need? One is barium chloride salt and sodium sulfate salt. Okay, so the reaction between aqueous barium chloride solution and sodium sulfate solution will give a precipitate barium sulfate and sodium chloride. Here barium sulfate is precipitated at the bottom of the test tube at the end of the chemical reaction. Let us verify this with an activity. Take a pinch of sodium sulfate salt. Next, take another test tube. Take a pinch of barium chloride salt. Prepare the aqueous solution of barium chloride and sodium sulfate. See this, what I am doing? Now I am preparing salt solutions of aqueous solutions of sodium sulfate. This is sodium sulfate and this one is barium chloride. Aqueous solutions of sodium sulfate and barium chloride. Now see, I poured the two solutions in another test tube. Observe this carefully. Observe this carefully, children. Observe this. See this one. A white undissolved solid is formed at the bottom of the boiling tube. This undissolved solid which is present at the bottom of this boiling tube is known as what we call it precipitate. Observe this carefully. See this one. You will find a powdery undissolved substance at the bottom. If I keep this boiling tube for some time without any disturbance, you will clearly observe the precipitate, formation of precipitate. See this one. Observe this carefully. White precipitate is formed at the bottom of the boiling tube. So with this, what can we conclude? We can conclude that in a chemical reaction, precipitate is also formed. This is one of the characteristics of a chemical reaction. So with this experiment, we can say that precipitate is formed in a chemical reaction. Are you clear about that one? Okay. What are the materials we needed here to prove this activity? To do this lab activity? One is the barium chloride. Another one is the sodium sulfate. You prepared what is the procedure we followed here? We prepared the fresh salt solutions of barium chloride and sodium sulfate. We mixed the two solutions in a separate boiling tube or in a conical flask. Okay, so as soon as they reacted with each other, they touched with each other, they mixed with each other, you found a white precipitate at the bottom of the reaction. Undissolved substance is formed, undissolved solid is formed at the bottom of the test tube. So with this we can say that precipitate is formed in the chemical reaction. Children, we discussed the characteristic properties of chemical reaction. Now, let us define what is a word equation. A reaction which is expressed in words is called a word equation. What is that? A reaction which is expressed in words is called a word equation. For example, magnesium plus iodine gives rise to magnesium iodide. I have written this chemical reaction in words only. Hydrogen and oxygen gives rise to water. So, hydrogen and oxygen gives rise to water. So, I have written this equation in words. So, this is a word equation. And sodium reacts with the chlorine to give sodium chloride. This is also written in words. So, all these reactions which are expressed in words is called a word equation. Magnesium plus oxygen, magnesium oxide. So you expressed that chemical reaction in words. So such a reaction which is expressed in words is called a word equation. So it is very difficult every time to express a chemical reaction using the words. So we express the chemical reaction using the symbols and formulae of the elements and compounds formed in the chemical reaction. Such a reaction which is expressed the chemical change using the symbols and formula is known as chemical equation. So what is a chemical equation? The symbolic representation of a chemical change. The symbolic representation of a chemical change or a word equation using the symbols and formula is called chemical equation. So we are using the symbols and formulae. So we use the symbols for elements and formulae for the compounds. To write the elements, one should remember to consider atomicity. Next, to write the compounds formed or compounds taking part in the chemical reaction, we have to consider the valency. Here I will explain. See this one. Hydrogen and oxygen reacts together to give water. These are the reactants. Hydrogen and oxygen are the reactants, and new substance, that is a product, is formed known as water. So what is the symbol of the element hydrogen? H. The symbol of oxygen is O, but the atomicity of hydrogen is 2. So I have written H2. One molecule of hydrogen consists of 2 atoms, and one molecule of oxygen consists of 2 oxygen atoms. So H2 plus O2 gives rise H2O. Why I have written H2O? H2O is a compound formed due to the combination of hydrogen and oxygen. So while writing the formula of a compound, you have to consider the valency. In your previous classes you studied crisscross method. The valency of oxygen is 2 and the valency of hydrogen is 1. So by crisscross method, the formula of this compound water is H2O. Okay, so hydrogen and oxygen gives rise to water. So I didn't wrote the word equation. Simply what I did, I expressed using the symbols and formula, okay, of this chemical change. So such a reaction which is expressed using the symbols and formula is known as chemical equation. Another example, see this one. Magnesium, the element magnesium reacts with oxygen. Magnesium and oxygen reacts with oxygen to give magnesium oxide. So magnesium is a metal and oxygen is a gas. So a new compound is formed, magnesium oxide. Now magnesium, the atomicity of magnesium is 1 only. The atomicity of oxygen is 2. So magnesium always takes part in the chemical reaction as a monoatomic molecule. Monoatomic molecule. So magnesium plus oxygen gives rise to magnesium oxide. So magnesium oxide is a compound. So I expressed this magnesium oxide using the formulae. Using the formulae. Okay. In the same manner, see this one. Barium chloride plus sodium sulfate. These two are the compounds. These are the reactants that are taking part in the chemical reaction. A new substance is formed, barium sulfate. This is a precipitate, and sodium chloride is also formed. Barium sulfate is formed and sodium chloride is formed. Okay, now barium chloride formula is BaCl2 and sodium sulfate is Na2SO4 and barium sulfate is BaSO4 and sodium chloride is NaCl. NaCl. So I have written these compounds using their formulas. Using their formulas. So this reaction is known as chemical reaction is known as a chemical equation. So when you express a word equation using the symbols and formulae, it's called chemical equation. We have to remember one thing: while writing the elements we have to consider the atomicity, and while writing the compounds we have to consider the, what is that, valency. Children, we discussed what is a physical change and what is a chemical change, and what is a word equation, what is a chemical equation. Next we did 4 activities to prove the characteristic properties of chemical changes or chemical reactions. Here is an assignment. You click the document attached here. Okay, you will get the assignment. Thank you, children. I hope you have liked my class and you have enjoyed my class. Don't forget to watch my channel for further videos. This is chemical equations part 1. In part 2, we will discuss what is a balanced equation, what is the need to balance the chemical equation, and few problems related to balancing chemical equation. Thank you, children.